Let's look at an application of the ratio test. In this example, we've got a series with factorials in both numerator and in the denominator, and as we've discussed, when that's the case, the ratio test is a good test to try. So, in this case, our a sub n's are n factorial cubed over 3n quantity factorial. So the ratio test is applied by looking at the ratio a sub n plus 1 over a sub n and taking the limit of that as n goes to infinity, all in absolute values. So here we're going to get limit n goes to infinity. A sub n plus 1 is just found by replacing n by n plus 1 here, and doing that we end up with n plus 1 factorial all cubed divided by 3n plus 3 factorial. That's because if n is replaced by n plus 1, this expression becomes 3 times the quantity n plus 1, that's 3n plus 3. Now we need to divide by a sub n. Dividing by a sub n is the same as multiplying by the reciprocal, and so that's what I'll do here. Okay, and now we need to simplify. So simplifying, you'll notice that the 3n plus 3 factorial can be written as 3n plus 3 times 3n plus 2 times 3n plus 1 times the quantity 3n factorial. So I'll do that next. The limit as n goes to infinity. So in the denominator here, I'll have 3n plus 3 times 3n plus 2 times 3n plus 1 times 3n factorial. So that's just this expression right here expanded out in a way that'll be helpful. To see that it's going to be helpful, I'm going to put this 3n factorial over the top. And you can see what's going to happen in the next step. Of course, the 3n factorial here and that 3n factorial are going to cancel. Okay, now what's left? Well, we've got an n plus 1 factorial right there. Of course, we can write that as n plus 1 times n factorial. So if we do that next, we'll have n plus 1 times n factorial. The entire expression is cubed, so I'm going to cube each one of these separately, just using distribution of the exponents over that multiplication. That is divided by our n factorial cubed, and now we can see what cancels here. That and that cancel, that and that cancel, and so this simplifies to the limit as n goes to infinity of n plus 1 cubed over 3n plus 3 times 3n plus 2 times 3n plus 1. This is a rational function in n. It's a rational function in n. The degree of the numerator is going to be 3. The degree of the denominator is going to be 3. We know that in this case, the limit as n goes to infinity is going to be the coefficient of the highest degree term in the numerator. Well, that'll be a 1. This will start out 1n cubed. And the coefficient of n cubed in the denominator is going to be 27. So if we simplify that, we end up with 1 over 27, and that is less than 1. So we know that our original series is absolutely convergent. Therefore, this series which I'll just denote by an since we've identified an right here, n goes from 1 to infinity, is absolutely convergent by the ratio test.